discuss about body's contact in contact with vertical surfaces. So here in this case, so many cases are there. So we can explain first case, case 1. If we consider a mass of the body here, contact with the wall, vertical wall, then a horizontal force is acting on the body in perpendicular to the wall in this way. So now normal reaction is acting on the wall onto the block. It's opposite to the pressing force. Now weight of the block acting vertically downwards and frictional force in between the block and the vertical wall acting upward direction in this way. So here when the body is under the equilibrium position, when body is stationary, upward forces equal to downward forces. Upward forces is equal to downward forces. So here upward forces is frictional force, downward force is mg. So Fs equal to mg. You know that Fs equal to mu s into n. Mu s into n is equal to mg. So here n is balanced to the pressing force. So here n equal to f. So now this value is substituted in equation mu s into n equal to mg. So therefore mu s into here n is f is equal to mg. So therefore f equal to mg by mu s. Here f means pressing force acting on the body is mg by mu s. Here mu s is the coefficient of friction between the block and the vertical wall. Here mg is the weight of the block. So this is a case 1. Now we discuss second case. So here in the case 2, a book is held in between the two hands. This diagram is in this way. So this is the two hands and a book is held in between two hands. This is the book. Its weight is vertically downwards. But the frictional force in between the book and the hand is vertically upward direction. So here there are two hands, two frictional forces are acting on the book in upward direction. So now the book is held in between the two hands, the book is stationary, the total weight of the book is equal to total frictional force. So when book is stationary, book is stationary, total weight of the book is equal to total frictional force. Total frictional force. Now, here total weight, that is mg, is equal to Fs and Fs. Fs plus Fs. So in this situation, the pressing force is in this way. Normal reaction is in this way. In the other hand, pressing force is in this way. Normal reaction is in this way. So now here F equal to N. So here pressing force F equal to normal reaction. So therefore mg equal to Fs plus Fs, 2Fs. So mg equal to 2 into Fs means mu s into N. So now mg equal to 2 into mu s into, here n equal to F. So therefore F equal to mg by 2 mu s. So here F is the minimum force acting on the book of each end. So now the net force acting on the book is F minus F, that is the 0. So here F means the minimum force acting on the block of each end. So this is the case 2. Now we discuss case 3. Case 3. So here a block of mass m is contact on the vertical wall in this way. So here pressing force is acting on the block in this way, but normal reaction is acting in this way. Now the weight of the block is vertically downwards. Now a minimum pushing force, that is F minimum, is acting on the block in upward direction. Then in the same case frictional force is acting downward direction. So therefore the minimum pushing force acting on the block F minimum equal to mg plus Fs. mg plus Fs. So here F minimum equal to mg plus Fs means mu s. So here there is no Fs, here it is a Fk, that is the kinetic frictional force, because here the body is moving upward direction, moving in upward direction. So therefore F minimum equal to mu g plus mu k into N. So here N equal to balance to the pressing force, that is the F. So this is the pressing force. This is a minimum force acting on the block parallel to the wall, vertical wall. So therefore F minimum equal to mg plus mu k into N. Here N equal to capital F. Here N equal to capital F. Now we can find out the work done by the pushing force. So here work done W equal to F minimum into displacement. Here S is the displacement covered by the block on contact to vertical surface. So therefore W equal to F minimum is mg plus Fk into S. So this is the work done by the minimum force acting on the block along the parallel to the vertical surface. So this is the case 3. Now case 4. Case 4. So here this is one of the vertical wall. If you consider a block of mass m is contact in vertical surface of the wall, rough wall. Now a pushing force, the value of P of pushing force acting on the block, making an angle theta with the horizontal, making an angle theta with the horizontal. So in this way same angle is produced. So therefore here P is resolved into two components, P cos theta and P sin theta. So its weight is vertically downwards. So frictional force is vertically upwards. So now normal reaction is in this way. So here the block is stationary, contact to the vertical surface. Now when the block is stationary, upward force equal to downward forces. So here upward forces equal to, that means downward force is mg, upward force equal to Fs plus P sin theta. Fs plus P sin theta. So therefore mg equal to Fs means mu s into n plus P sin theta. So here normal reaction is balanced to the P cos theta. Normal reaction is balanced to the P cos theta. So now this value is substituted in equation this way. So here mg is equal to mu s into n. N means P cos theta plus P sin theta. So therefore mg equal to P common, this is the mu s cos theta plus sin theta. So here P equal to mg by mu s cos theta plus sin theta. So this is the minimum pushing force acting on the block when the block is at rest position. When the block is at rest position in contact with the vertical wall. Next, case number 5. Now we discuss case number 5. If we consider a man of mass small m is held in between two rough vertical walls. Its diagram is so in this way. Here a man of mass small m is held in between two vertical surfaces. Now the man is stationary in between the two walls, rough walls. So here its weight is vertically downwards, but pressing force with the hands in this way, normal reaction in this way, pressing force against the wall by legs in this way, but normal reaction in this way. Now the man is stationary in between the wall. The man is stationary in between two walls, two vertical walls. So here total weight of the body is vertically downward direction, and frictional force F1 and F2. So here there are two sides of the frictional force acting on the body in vertical direction, total weight of the body vertically downward direction. So now when a body is stationary, upward force is equal to downward forces. So now total weight of the person mg equal to F1 plus F2. So mg equal to F1 means mu1 n plus mu2 n. Mu1 n plus mu2 n. So here pressing force is equal to normal reaction. Now this value substitute in equation. So therefore mg equal to mu1 f plus mu2 f. So therefore mg equal to f into mu1 plus mu2. So therefore f equal to mg by mu1 plus mu2. So this is the minimum pressing force acting on the walls of each side is f equal to mg by mu1 plus mu2. Thank you.